So 1.6, examples 2 and 3. If we look at example 2, we have another graph with a couple of vertical asymptotes. So at the vertical asymptotes, we're going to label left, right, and look at those limits. So on the left of x equals 2, we see the graph goes up on the left and there's nothing there on the right. So that limit is positive infinity. On the right, there was nothing on the top, so we look at the bottom. On the left, there's nothing, but on the right, that graph keeps going down. So that right side limit is negative infinity. Negative, of course, because it's down. On the other vertical asymptote at x equals 3, label it left, right, and look at those limits. As we look at the left, there's nothing on top at the left, but on the left, we do go down. Remember, it's to the left of the dotted line. So that left side limit is negative infinity. Left limit would be negative infinity. The right side limit, there was right side is going up. Okay, that right side is going up. So that limit is positive infinity. As far as the end behavior goes, what we have as the graph approaches the far left and the far right, this is called a slant asymptote. And we'll learn more about those in a future unit. What we need to realize right now is that it's a line with a slope and a y-intercept. So as we look at the far, far left of the graph, we see where we're curving towards this asymptote and we keep going down, 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 down. So the y's, f of x, are going down. So that is a negative infinity for that limit. Then on the far right of the graph, we're over here. And we see this little shape kind of swooped, and now it's coming towards that asymptote. The y direction of that is going up. So that is a positive infinity for that limit. Now, let's look at example 3. Again, we have a couple of vertical asymptotes, and we have some end behavior. So look at the vertical asymptote at -1. We have a left side and a right side. We have a left side and a right side. So on the left of that graph, the y's are pointing up. It's a positive infinity. On the right of that asymptote, the graph points down, so that limit is a negative infinity. Look at the other asymptote, label left, right, left, right. As we look at the left of that asymptote, the graph is going up, and it's also going up on the right. So both limits at that asymptote at x equals 2, both of those limits are positive infinity. That can happen. Then on the end behavior, what the graph is doing on the far, far ends of the graph, we have another slant asymptote here. So looking at the far left of the graph, that y is coming closer to the line, which is going down. It's a negative infinity. On the far, far right of the graph, we're going up towards that slanted line, so that limit is infinity. Now, on example 1, the first one on that front page, okay, the end behavior had a horizontal asymptote at y equals 3. So the left and right end behavior is approaching 3. For example 2, and again for example 3, the end behavior was a slant asymptote with an equation with a slope and a y-intercept. Okay, so the left went to negative infinity and the right went to positive infinity. On example 3, there was another slant asymptote with its equation, y equals x minus 2. The left went to negative infinity and the right went to positive infinity. Limits are asking you what direction the y values are going as x's are close to something. All right,